Okay, let's unpack this. Welcome to today's deep dive. We are jumping right into something that I think completely flips the script on how we look at artificial intelligence.
It really does. I'm excited for this one.
Yeah, so today we're looking at the Satori light paper, and the core mission of this deep dive is to basically tear down why the current AI paradigm is, well, kind of flawed.
Right.
And we want to argue for this decentralized, biologically inspired approach to predicting the future. Because it's not just for stock prices, it's for modeling everything.
Exactly. Everything from weather to complex business production.
Right. So to start, I want you to picture this. You're looking at this incredibly detailed, high-resolution photograph of a busy city intersection.
Okay.
You can zoom in. You can look at every single pixel, see where the shadows fall, read the license plates.
Yeah.
It's a flawless, static image.
Right. But it's frozen.
Exactly. It's frozen.
Yeah.
And when most people think about how modern AI works, they picture something like studying that photograph.
Which is, it's an impressive technical feat, but it completely strips away the most critical dimension of our existence, which is time.
And that is the exact problem. Because imagine if, instead of analyzing a photograph, you had to actually drive a car through that moving traffic.
Oh, man. Yeah.
Staring at a static map of where the cars were 5 minutes ago isn't just useless, it's actually dangerous.
Yeah, you have to anticipate where things are going to be in 5 seconds.
Right. True intelligence is about navigating the flow of traffic. But right now, almost all the tech giants are spending billions to build bigger magnifying glasses to look at photographs.
What's fascinating here is that it represents this fundamental philosophical divergence, like how the industry approaches intelligence itself. The prevailing belief right now is that if you just gather a big enough snapshot of data, intelligence will somehow spontaneously emerge.
Which is where the Satori leap paper comes in, because it upends that entirely.
It does. It makes this critical distinction right out of the gate between spatial patterns and temporal patterns.
Right, the data sets versus data streams.
Exactly. Current AI models are obsessed with spatial patterns. In practical terms, that means they are obsessed with datasets.
And data sets are static.
A dataset is the ultimate spatial pattern. Think about the life cycle of AI right now. A corporation scrapes petabytes of data, they clean it, and they feed it into a neural network.
The batch training thing.
Right, batch training. It takes months and millions of dollars. But the fatal flaw is that the second that dataset is finalized, it starts to age.
Because the world didn't stop moving while the computers were crunching the numbers.
Yeah, the world is dynamic. Reality is this continuous, unending flow. So the Satori architecture argues that the fundamental data structure of the universe isn't a data set, it's a data stream.
A data stream is alive. It's always adding new observations.
Exactly. So to understand the world, AI needs to do what the paper calls online learning, updating its internal model incrementally in real time.
Which makes so much sense. Anyone who has used an AI chatbot has felt this, right?
Oh, absolutely.
You ask it about a recent event, and it says, my training data cuts off in January 2023.
Yeah, it's incredibly frustrating.
It's like asking a system trained on a photograph to comment on the traffic right outside your window.
It's blind to anything after the shutter clicked.
But, okay, wait. If true intelligence requires processing this constant flow of real-time reality, doesn't that require a supercomputer?
You would think so, yeah.
Because the source says you can run a Satori neuron, which is what they call a node on the network, on an old home PC, or even a $35 Raspberry Pi.
Right.
How is that even possible if we're ingesting live global data streams?
Well, the solution comes directly from biology. The source spends a lot of time analyzing the human brain compared to modern silicon.
Okay.
If you measure the raw computational speed of a biological neuron, it is staggeringly slow.
Wait, really?
Yeah. A modern CPU operates in gigahertz, executing billions of cycles a second. A human neuron fires maybe 100 times a second.
So our brains are actually terrible processors.
Relatively speaking, yes. Orders of magnitude slower than a cheap smartphone.
Wow.
Yet you can stand on a field, track a baseball through the air, anticipate wind resistance, and catch it in real time.
That's a good point.
And the brain manages this through two things. First, it treats time as the primary dimension, anticipating the immediate future. And second, massive parallelization.
It's not one fast processor. It's a vast decentralized network of slow processors.
That is the biological secret. And this is where decentralized AI usually hits a brick wall.
Why is that?
Because if developers try to build a decentralized network using the old dataset approach, the nodes have to constantly share their model weights with each other to stay in sync.
Oh, I see. They'd have to send massive files back and forth,
Gigabytes or terabytes of internal math just to update the central hive mind.
which would totally bottleneck the internet.
Exactly. The communication overhead makes it slower than just using a centralized server. But Satori circumvents this by shifting focus to the temporal domain. Satori neurons are decoupled. They only share one piece of information, their predictions.
Oh, that is such a brilliant shortcut. They don't share how they got the answer, just the answer itself.
The prediction is the only required output. And because every future prediction informs the neighboring models, you get massive parallelization without the crushing overhead.
That explains the hardware thing. The heavy lifting is inherently distributed, so you can use a Raspberry Pi.
Precisely.
And this creates that unique redundancy that Tex talks about, right?
Yes, unique redundancy is key.
Because even if 1,000 neurons are all trying to predict the exact same thing, like the temperature in Chicago tomorrow at noon,
Right.
they aren't just redundant clones doing the exact same math. Every single neuron is listening to a slightly different set of data streams.
Exactly. A neuron in Ohio might look at historical barometric pressure.
And one in London might correlate it with commercial flight traffic or ocean temperatures.
Right, so when the network averages them together, you aren't just getting a louder version of the same answer. You get this nuanced, multidimensional wisdom of the crowd.
That is so cool. Okay, here's where it gets really interesting, though. Because if this network is just churning out predictions of objective reality, that feels very different from how large language models work right now.
Oh, vastly different. The light paper goes pretty hard on the existential threat of centralized LLMs.
Right, it touches on what they call the alignment problem.
This raises an important question, right? So the alignment problem is probably the most fiercely debated issue in tech. How do we ensure AI acts according to human values?
And the problem the text points out is that when a big corporation builds an LLM, they have to choose an error metric.
They need a way to tell the AI it did a bad job.
Exactly. But because these are publicly traded companies, their overarching value is usually just not giving offense.
Right.
So the error metric isn't objective reality, it's the corporate party line.
And if an AI is economically incentivized to appease human sensibilities and flatter biases and avoid controversy, it fundamentally cannot be trusted as an arbiter of truth.
It's untethered from reality.
The paper argues that feeding an AI humanity's contradictory propaganda and then penalizing it for offending people just breaks the machine's connection to the real world.
But with Satori, if a central corporation isn't writing the rules, the only judge is whether the prediction actually came true.
That is the elegance of a decentralized prediction network. The real world is the uncompromising error metric.
You can't spin a prediction. Either it was 72 degrees in Chicago or it wasn't.
Exactly. You can't apply PR to a forecast. As the author states, a model that accurately predicts the future of a system inherently understands the mechanics of that system.
So a future oracle is by definition a truthful AI.
Yes. And because it's decentralized to token holders, the control over what the AI pays attention to isn't dictated by a boardroom.
That makes total sense. So let's talk about real-world applications. Because when people hear future prediction in crypto, they just think of stock prices.
Sure, yeah.
But the text explicitly mentions corporate hierarchies and production lines.
The modeling potential goes way beyond financial speculation.
Right. So if this can model a corporation where low-level employees handle daily details and executives handle multi-year positioning, could a business actually use Satori to map its entire physical production line as a series of data streams?
Oh, absolutely. A modern factory floor is just a complex web of intersecting data streams.
Like what? Like machine temperatures?
Machine temperature, supply chain logistics, inventory levels, energy consumption, shift schedules.
So instead of a manager waiting for a delayed shipment to arrive before realizing there's a problem, they could have Satori constantly predicting the future state of the whole operation.
Exactly. If the network predicts a parts delay is going to clash with scheduled maintenance 3 weeks from now, you adjust the maintenance today.
Wow, that could save a company millions in downtime.
And the text outlines 2 visions for this. The first is the public good.
Right.
This envisions predictions on open, unencrypted data streams being freely available, like city temperatures or global traffic.
So the Satori Association wants to build an interface that basically a search engine for the future.
Right. You just type a query like, expected congestion at the Port of LA next Tuesday.
And you instantly get a crowdsourced AI prediction.
Exactly. And then there's the second vision, which is the market ecosystem.
That's where the complex business stuff comes in.
Right. Businesses can post bounties or host competitions for highly specific forecasting on private systems.
Oh, okay.
If that factory manager needs a robust forecast on proprietary data, they leverage the decentralized brainpower of Satori. Professional data modelers can compete to earn wages.
See, I have to push back on that incentive structure for a second.
Sure, go ahead.
If there is this massive financial incentive to get better predictions, won't this just lead to centralization?
How do you mean?
Well, the light paper uses Bitcoin as a cautionary tale. Bitcoin started out perfectly decentralized. Anyone could mine it on a laptop.
Right.
But because it relied on simple hashing, it became commoditized. Now you need a massive warehouse of ASIC miners in a desert to compete.
That's true.
Won't massive server farms eventually push out the Satori people running Raspberry Pis?
The source addresses this directly by drawing a line between hash mining and what it calls intelligence mining.
Okay, what's the difference?
Well, hash mining, like Bitcoin, is a brute force mathematical guessing game. It's static, so it's easy to hard code into specialized silicon chips.
It's just dumb computation doing one math equation really fast.
Exactly. But intelligence mining is a fundamentally different task. It requires context.
Right.
It requires memory bandwidth, adaptation, and correlating messy data.
So you can't just build a dumb chip to guess the future faster.
No, it's notoriously difficult to hard code intelligence into specialized hardware. The best tools we have are standard CPUs and GPUs. Plus, predicting a data stream requires bounded context. Piling massive hardware onto one data stream gives you diminishing returns compared to the network's unique redundancy.
So it actively resists aggregation.
Yes. A dedicated data scientist might win a specific high-paying bounty, but the average user can still earn tokens by providing unique, valuable predictions.
And looking at the tokenomics in the paper, it seems engineered to reinforce that balance.
It is very intentional. There was no pre-mine, no insider airdrops for venture capital to dump on retail.
A completely fair launch.
And transparency is prioritized. The total supply of Satori tokens is strictly capped at exactly 4,086,709.
Which is such a specific and small number compared to projects that mint billions of tokens.
Right. It forces the network to truly value the intelligence.
And the halving schedule starts in 2026.
Yes. In 2026, exactly 1 million coins will be minted. And over 2 decades, that emission drops. By 2032, it's about 527,000.
Okay.
By 2040, roughly 125,000. And by the end of the schedule in 2048, the network only mints around 80,000 coins a year.
Stretching it out to 2048 prevents early adopters from monopolizing the system.
Exactly. It ensures a stable environment for the miners.
But the most revealing part to me was how the tokens are distributed.
Yeah.
You can always tell what a system values by who gets paid.
Oh, absolutely. The reward split is heavily skewed by design. 84.9% goes directly to the predictors.
The actual neurons doing the forecasting.
Right. Meanwhile, the people running the Nostr relays, just carrying the data, they only get 0.1%.
Wow, that's
The
terrible.
developers get 15% for protocol support.
So by giving almost 85% to the predictors, they're heavily biasing the incentives toward actual brain power.
Exactly, rather than just rewarding dumb bandwidth.
So what does this all mean? Looking at the whole architecture, the argument is just incredibly compelling.
It really is.
The industry obsession with static datasets is a dead end. By embracing the reality of time as a data stream and mimicking the brain's parallelization, Satori is proposing an AI that predicts the future.
A truthful AI.
Right? Immune to the corporate alignment problems of modern LLMs. And it's lightweight enough to run on everyday hardware.
Which creates a truly decentralized oracle for modeling anything. It requires a profound shift in how we think about machine learning.
It does.
But there is one final concept from the light paper that I want to leave you with regarding the long-term impact.
Okay.
The author quotes the Tao Te Ching. They say, "Let your workings remain a mystery, just show people the results."
That is the perfect mantra for a network that refuses to share its internal model weights.
It is fitting, but they point out this fascinating, almost accidental byproduct of the whole ecosystem.
What's that?
If you build a network that is constantly predicting the baseline norm of thousands of societal data streams, you get an incredibly powerful tool for free: global anomaly detection.
Oh, wow. Because if it knows what should happen based on historical and real-time context, you instantly know when something unexpected occurs.
Exactly. If it perfectly predicts the norm, any sudden deviation is instantly highlighted. The network becomes a global sensor for the unexpected.
That is wild.
Which forces us to ask a profound question. If a decentralized network starts predicting the future of our daily mundane data streams, what hidden patterns or structural anomalies in our society is it about to expose?
Things we just couldn't see ourselves because we were too busy driving in the traffic.
Precisely.
We spend so much time staring at the static photograph, we might not realize the road we're on is about to change direction. It is going to be amazing to see what a network like this reveals when it finally looks ahead